been absent or if you need some extra practice, this is page 24 in your packet, and this is the review for the final test. So the first one we are solving by graphing. So we need to, they're already in y equals form. So I can start with my y-intercept, which is -1. And then my slope is 2/3, so that means I rise 2, run 3, and make a dot. And I usually like to maybe do a couple dots, so I make sure that, and you can even go the reverse direction, so instead of going up 2 over 3, I go down 2, 3 to the left, because we want to make sure that our lines are landing at the correct point. Okay, this one is also starting at -1, so you could have probably figured out that that was our solution to begin with, because they're starting at the same point. My slope is a -1/3, that means I go down 1 and over 3. So there's my two lines. My solution is the point where they cross, and the name of that point is 0, -1. Okay, for this one, you can see one of them is already in y equals form, but the other one is not, so I need to put it in y equals form. I need to get y by itself, so I need to move 3 to the other side. So I'm going to -3 to both sides, so that's gone. So I have y equals 3x minus 3. Okay, so I'm starting at a -3. That's my start point. So you always start with the y-intercept. My slope is 3. You can put it over 1, so rise 3, run 1. Again, the best way to do this is, because I do go through these kind of quick, is that you should be pausing the movie as I go through it. Do the problem. If you get stuck, you can watch a little bit of the movie to get some help, but as soon as you get to a point you know what to do, then do it on your own. Okay, again, this one we're starting with 4, so I make a dot at 4. My slope is -1/2, so it's a negative slope. It means the line has to go down, so I go down 1 over 2, and you can see, boom, that is where they are crossing, and that point is 2, 3. Again, when you name a point, you go over 2, up 3. The one that we did on the pre-test, we've done similar story problem type things before, so let me just quick make up a problem. So let's say that we have people that are saving money. So let's say we have Jill, and she is saving $2 per day. So her equation is y equals 2x. And then let's say we have another person, Linda, and she is saving $1 per day. She's saving a whole lot, but she already started with 5. So those are my two equations. So this represents Jill and this represents Linda. So if I wanted to graph those, and actually I do have a paper right here that I can use this graph. Okay, so remember Jill started with nothing and is saving 2 per day. So her slope, okay, right here is 2 over 1. So that means from here I need to go up 2 over 1, up 2 over 1, and I keep going a few. Okay, Linda, she started with 5, and remember she is saving $1 a day. So she starts at 5, and she is saving $1 per day. So she needs to be going up 1 per day. And you can see if you keep going, you can find the spot where they cross. So even though this is a story problem, we are still solving by graphing. And you can see that right here, if I follow this down, so on day 5, both of them saved $10. So that's just an application of solve with graphing that you can use with a story problem. All right, the next one we're going to do is solve with substitution. So with substitution, we find which one is solved for x or y. So it happens to be this one. And so this is what y equals. That means I can put that in for y in the other equation. Now if I want to put a 1 here, I can put a 1 there. Anything times 1 is itself. Okay, so I'm going to write this equation out. So it's 3x minus 1. There's my y, so I need to put that in parentheses. If it's a plus sign here, you don't need the parentheses, but because it's a minus, or if there's a number here other than 1, you need to distribute that. So we do need to distribute that minus sign. Okay, so I wrote the y, and then I have equals 4. So here I need to distribute. So I have 3x minus 1y. It's a negative 1 times 2, so it's going to be a negative 2 equals 4. Now you guys are doing really good at combining your variables, but what I've noticed is that you're so used to like doing like a plus x, but these are on the same side. When they're on the same side, you don't have to do that. You just combine them. It's a 3x minus a 1x. They're already on the same side. So we're just simplifying that, and that is a 2x minus 2 equals 4. Again, we're trying to solve for x, so I'm trying to get x by itself. So my last step is divide by 2. I need to get rid of this. So I'm going to add 2. Now here's where we have to do it on both sides, because we're trying to move the 2 to the other side. Okay, so that's gone. So I have 2x equals 6, and then my last step, divide by 2. So x equals 3. So I'm going to put the 3 in the x, where the x coordinate goes. We still have to solve for y, so we look at which equation looks easier. Obviously the first one. So all I have to do is put 3 for x. So put 3 right on top of the x. That's what x is. 3 plus 2 is 5. So that means y is 5. Okay, we have another solve with substitution. Okay, again, this is what y is. I need to take that and I need to put it in place of the y in the other equation. So I'm going to write this out. Okay, I put it where the y is. I just wrote that for the y, and then I write the rest. Okay, I need to get my variables together first. You can see here they are on opposite sides. So that's where I need to do the same thing on both sides. I like to start, if there's a negative, I for sure like to do the opposite of that to get rid of it. So I'm going to add an x on both sides. So it stays balanced as long as you do the same thing on both sides. The equation stays equal. That's gone. Don't forget to drop down the negative 1. And then I have a 2x plus a x is 3x plus 14. Okay, now I need to get my numbers together. So I need to move the 14 to the other side. So I do need to do the opposite to move it on the opposite side. That's gone. Negative 1 and negative 14 is a negative 15 equals 3x. Okay, now we're on the last step, and I'm going to divide by 3. So 15 divided by 3 is 5, and I have a negative, so it's going to be a negative 5. Now I need to go back, and I need to solve for my y. So again, you can put it in either equation. I'm going to use the bottom one this time. Okay, so negative 5, and if you want to use a calculator, you can use a calculator, so you can punch in the whole entire thing. Okay, so I type in my 2. When there's no sign, that means times. So you have to write times, and then it's a negative 5. Make sure that when you're doing the negative, you are using the negative sign on your calculator, not the minus sign. Okay, so negative 5, and then plus 14, and equals, and there's my y, 4. Now, if you did the other equation, you're going to get the same thing. See, if I put negative 5 here, so it's a negative 5, which cancel out, so it's a 5, and 5 minus 1 is 4. See, we get the same answer, so we know we did it right. All right, the next two we're doing solve with elimination. Okay, and we have one that's an easy elimination, and then we have another one where we have to do a little bit just to do the elimination. Okay, so for this one, when we do elimination, we need our x's, y's numbers lined up, draw a line, put a plus sign. So we're adding the two equations together. Okay, you can see here's my opposites, so they cross out. 6 plus 2 is 8y, and 14 plus 10 is 24. Okay, then I'm on my last step already, divide by 8. So y equals 3. So see how quick that is? That one's quick, but now we have to go back and we have to solve for x, and this takes a little bit more work. I'm going to use the second equation, so we write out the equation for x plus 2, my y is 3, equals 10. Okay, 2 times 3 is 6. Again, don't try to do multiple steps at once or you might make a mistake. Just take the time and write out your steps. Okay, then I need a minus 6 on both sides, because again, we're trying to solve for x in this case. So 4x equals 10 minus 6 is 4. Divide by 4. So x equals 1. So the solution is 1, 3. Remember, y is 3, so the 3 has to go in the y spot. This one, you can see our x's and our y's are lined up in our numbers, but we don't have opposites anywhere. And I think you're going to have to do this on one of your story problems. You need to make them to be opposites. So I would like there to be a 2 in front of this y. So to put a 2 there, you can't just write a 2 there. That changes the problem. But you can multiply everything by 2. It just doubles the equation. We're just doubling it. We're multiplying everything by 2. So each of these things need to be multiplied by 2. I'm going to write it underneath so that they're lined up. So 2 times 2, 4x. Okay. That's where I get my negative 2. And then 2 times negative 2 is negative 4. So now these are the equations I'm using for elimination. Okay, you can see these are opposites, they cross out. We like that. These are opposites, they also cross out. So we end up with 0 over here. 4 and negative 4, they are also opposites, so they cross out. 0 equals 0. Does equal 0? Yes. So that means infinite solutions. That means any number you put in here for x, if you pick any number for x and y, okay, and you can try it. Like, let's say I just pick, again, it has to be a solution, I guess I should say. So if I pick a solution for this one, it's going to be the same solution for this one. I'll go back to that if I have time. All right, let's look at the story problems now. So we have 2 different types of story problems. This story problem we're most familiar with. We've done a lot of these. So we have 2 different types of stores that have some different costs. So this kick and kayaks is $8 plus 3 per hour. Again, whenever you see the per, put the x. So the 3 goes with the x, and these are going to be y equals formulas. So 3x plus 8. Okay, the next one, you can see here's my 5, here's my per, so the 5 is what goes with the x in this equation, plus the 4. Okay, you can see these are in y equals form. This is the same exact type of problem as what we did over here with solve with substitution. We just take all our y stuff and we put it for y in the other equation. So I take all this stuff, put it for y in the other equation. So I'm going to write this, okay, equals the other part. Okay, again, our steps are we want to do our variables first, and I like to do the smaller one, so we try to avoid negatives. This one's smaller, so I'm going to minus the 3x on both sides. Okay, if you minus a 5x on both sides, you're going to see that a 3 minus 5 is a negative 2x. So this is where, if you do the smaller one, then hopefully we won't have negatives. So that's gone. Okay, here we have 8, 5 minus 3, 2x, and plus 4. Okay, then I'm trying to get x by itself, so I need to get rid of this number. I need to move it to the other side, so I have to do the opposite. Okay, so 4, and our last step, divide by 2, and usually by here you can see 2 times 2 is 4. So at 2 hours, they're going to cost the same, and now I just need to plug 2 into either equation. So 5 times 2, 10. 10 plus 4 is 14. So at 2 hours, both places cost $14. So that's one type of story problem, is where they give you the situation are y equals equations, and I would use substitution. You could also use graphing, but like we said, substitution is going to be more reliable than graphing. All right, then we have a different type of problem. We have Jill is selling student tickets and adult tickets. She sold a total of 20 tickets. So one of your equations is a simple equation. It's just s plus a equals 20. That's how many tickets she sold. The next equation is for the cost. It was $96, so for sure that's going to be our total. Okay, you can see the student tickets were $4, so I just need to put a 4 with the s, because each student is $4. It's $4 per student ticket. Remember, per, we're timesing it. Okay, and then the adult tickets are $6. So you can see that this is set up for elimination. But like I talked about before, it's not a quick elimination because they're not opposites. We need to make them opposites. So I like to choose the smaller number, so I see a 4 here. So I'm going to multiply this whole equation by -4. So I'm multiplying everything by -4. So I'm just going to write the -4. So you can see when I wrote this, I spaced it out because I knew what was coming. So rather than having to rewrite it, I left myself enough room that I can just put that there. So multiply this times -4, I multiply this times -4, and you need to multiply this by -4. Don't leave that guy out. Okay, now I'm adding the equations together. Okay, these cancel out. A -4 and 6 is going to be a 2a. Okay, and then at -80 and 96 is going to be 16. Then I divide, both sides by 2. Okay, and so a equals 16 divided by 2 is 8. And because I labeled my variable with a, I know my adult tickets is 8. If I sold 20 tickets, so 20 minus 8, 12 student tickets. So, and I'm sure that you could probably find other problems in your packet that we haven't done if you need to do any more practice.